Assalamualaikum and very good morning. My name is Wan Rusydi Bin Wan Supian. My matric number for AN180144. I am from the Department of Electrical Engineering and my supervisor was Dr. Inaja Aimi binti Muhammad Nordin. Today I'm going to propose my proposal for final year project FYP1, which is the title Electrical Machines Breakdown Monitoring System using the IoT, and I changed the title before this, which is the smart monitoring system in manufacturing industry, to the electrical machines breakdown monitoring system using the IoT. Here is a table of content that I'm going to present, which the first one was the introduction of the project, literature review, methodology, and also expected result that going to be what I expect a result that coming from this project. As a development technology that happened in our country and also for the worldwide, Internet of the Thing play a big role in advising the process of the system development, which is referring for the production line and also for the operation of the machines. Today, almost 45% of the world electricity generation and 70% of the total industry electricity consumer are powered by the electric motor, because without a motor they cannot run the machine, right? And most of the factory using a three-phase compared to one phase, because the three-phase accumulated with higher load will enable the machine to run in a large quantity. And encourage trend that change in system manufacturing, the industry 4.0 recognized as a key of the development industry IoT will enable the advanced smart monitoring during the operating time in the factory. Therefore, monitoring system should have towards as flexibility, quality, and also productivity. When the machine was operated, example like automatic glove packaging, automatic air leaking detection, and also water leak detection, when they are reached their maximum production capacity, sometimes breakdown what happen, we call as unplanned downtime. So they doesn't know they need to stand by, the operator need to stand by 24 hours, and in the result will towards to the high cost of operations, and require more labor to identify the problem that happened in the production process, which is they still had to run the process in the factory, but they must know the what cause and what the problem that happened for the machines. Therefore, development of IoT based on multi-system is essential to monitor the motor to provide accurate data during the unplanned shutdown, such as machine failure, power outages, and power consumption surge. There are three objectives must be fulfilled in this project. The first one, referring for the Internet of the Thing, to develop a prototype of IoT based on a motor breakdown monitoring system. The second one was develop the mobile software, which is to develop the mobile phone software applications which can receive and monitoring the data. The third one was analysis data, which is referring to analyze the effectiveness of the system based on accuracy of sensor measurement, processing, and data transfer time between measuring device and also the user phone. For the scope of the project, firstly, the system will using a three sensor to detect the data of the three parameter which is targeted in the motor. The first one, the motion sensor that used it to detect the motor. The second was the voltage sensor that used it to detect the motor voltage, and the third one was the current sensor used to detect the current motor that will be transmitted to the Internet of the Thing platform. And the data will be collected and stored in iCloud, where the user able to view and transfer the raw data and turn it into the graph and pie chart. And the multiple platform Ionic will be used to develop the monitoring applications. If the voltage or current or motion sensor condition are within the problematic range, the notification message will be displayed on the user mobile phone to alert the user about what kind of problem that happens in the machines. For the literature review, the ideal monitoring system architecture should consist of 5 layers. The first layer, known as a hardware layer, wireless connections layer, data accuracy layer, business logic layer, and also interface display layer. The hardware layer referring for the sensor where the is was placed in kind of the machines. The wireless connection layer referring for the uh, medium that you want to transfer the data, and data accuracy refer for the storage that you want to store the data, the raw data that happen, and business logic refer for the server that you want request the data, and interface display layer referring to the layer that represent how the user want to display the data in the GUI, graphical user interface, such as a computer, such as a mobile phone. The effect of the electrical machines breakdown. Firstly, the maintenance of the machines will goes raised to up to the higher cost, which referring for the motor on machines, and also the sensor of the machine, the parameter used, the hardware used, and the cost of the labor there. And therefore, it will also interrupt the production rate of the factory, which is we know the factory should be run 24 hours without problems. And from there, it will cause the environmental conditions to the worker, which is worker have to uh, stand by 24 hours in the control panel to monitor the system. There are mostly three things or component that use it as a prototype in automatic control device, which is the first one was Raspberry Pi, second one was the LoRa ESP module, and the third one was the Arduino Mega. For the part methodology that in this project, firstly I'm going to summarize the all literature review and then design the system of smart monitoring electrical breakdown, and try to propose the design to the supervisor. If not accepted, I'm going to design again. If accepted, I'm going to try goes to design the circuit and test the circuit. In the same way, try to coding of the mobile apps and synchronize the circuit with the GUI, graphical user interface of the mobile apps. And if there is more problem occur, I'm going to improve the system with a process method. As you see here is a block diagram which is involving the LoRa ESP32 as a transmitter and also receiver, and Raspberry Pi as a main analyzing of data will be happens, and also mobile apps. The current sensor, voltage sensor, and motion sensor will be connected to the LoRa ESP32 on the transmitter side, and also will be received by the LoRa ESP32 on the other side, which is a receiver, and that data will be transferred to Raspberry Pi, where all the kind of the calculations analyzing will be happen before be uploaded to the iCloud. When the user uh, click on the screen button icon for the current sensor data, voltage sensor data, motion sensor data, and also status transmitter and also receiver, the mobile apps will request on the server to send the data, and if successfully, the data will be retrieved on the iCloud and then transfer to the graphical user interface on the mobile apps. As you see here is a flowchart of electrical machines breakdown. When the electrical machines power on, the voltage sensor, current sensor, and also motion sensor will be connected. If the value can be read, the data will be sent to the LoRa ESP sender, goes to receiver and analyzed by the Raspberry Pi, and notification will be displayed on dashboard mobile phone application referring for the mobile apps. And if not, the breakdown facility electrical machine will be detected and display the message warning occur on the display. Then that notification will be transmit to the LoRa ESP32 by sender, and will be received by LoRa ESP32 receiver and then analyzed by the Raspberry Pi before the notification will be displayed on the dashboard on the mobile phone software applications. As you see here is the overall operational flowchart that happened in the system monitoring. Firstly, when the power was on, it will connect the mobile apps to the Raspberry Pi and check the connections on the LoRa ESP32 either on the both side. If the connection was established, if not, they're going to lose the game. If yes, the LoRa ESP will try to read the data on the receiver on the to sensor and also receiver side. And on the other hand, when the data was able to be read by the voltage sensor, current sensor, and also the motion sensor, data will be sent to the LoRa ESP. The status will be indicated for the LED, which is either the LED green on or LED red was on, but both LED as an output of the system, which is able to be sent or not. If you look on the other pictures, the picture of the flowchart, on the B side, status receive LED green on or LED red was on, and that's referring for the receiver. When the data transfer in the Raspberry Pi, the status will also receive whether the LED green on or LED red was on, and if yes, on the C side that happened in the Raspberry Pi, the Raspberry Pi will be undergoes the checking the data of the voltage sensor, current sensor, and also motion sensor. If the data was updated, the data will be analyzed and uploaded to the web server. If not, which is on the Raspberry Pi, the Raspberry Pi will be triggered a notification and uploaded to the mobile or to the phone software. If the user receive the notification, the status of the notification will be displayed on the graphical user interface, which represent the notification, voltage sensor, current sensor, and also motion sensor. And that's all the thing that happened on the system that I was proposed. This is a flowchart for the program LoRa ESP sender and receiver. Both are the same. The reason because the system started include the LoRa library and also wire and initialize and declare the voltage sensor, current sensor, and motion sensor on LED and also the pins that used there. The input of the voltage sensor, current sensor, and also the motion sensor will be read, and from there the LoRa ESP receiver will be start to transfer the data. If the status is yes, the LED green will be turned on. If no, LED red will be turned on, and both will be sent to the LoRa ESP receiver. And from the LoRa ESP receiver is still same, but the difference here is the packet of data will be transferred to the Raspberry Pi. This is the flowchart for the program Raspberry Pi and also mobile phone software. On the left side is the Raspberry Pi. On the right side was the mobile phone software. On the program Raspberry Pi, all the creation happened on the first step, and then read the packet of data that has been transmitted by the LoRa ESP receiver. If the packet of the data received, the status, the output, which goes to turn on the LED green. If LED green was happen, I means turn on, it will analyze the data according to the range that has been set, and if the data was updated, it will directly uploaded to the web server. And if the status indicate to the LED red, it will trigger the notifications, which is display the message that has been set up and upload notification to the mobile phone software application on the GUI graphical user interface on the phone. And on the right side, which referring from mobile phone software, firstly all the regression was there, and it will request if the user tick on the each icon on the graphical user interface, it will request the packet of the data from the web server and try to retrieve it. And if success, it will display on the graph, pie chart, and also table on the graphical user interface. As you can see here is schematic diagram circuit proposed, and on the left side, and on the right side was the graphical user interface that proposed on the phones that will be displayed on the phone, which is there is notifications, voltage sensor icon. And from first interface, for second interface, we goes to the graph and so pie chart, the reading of the voltage sensor, current sensor that has been clicked. And on the third interface, which goes to the table represent the set of the time, and also the condition of the sensors. Based on expected result, I'm hoping the prototype of the IoT based on motor breakdown will be developed. The second was the mobile phone software application to receive and display monitoring data will be developed. The effectiveness of the system based on accuracy of the sensor, measurement and processing, and data transfer between the measurement device and also user phone will be analyzed. So that's all from me. Thank you.